Digital pathology transforms traditional glass slides into high-resolution digital whole slide images. With the help of these whole slide images, pathologists can leverage the recent development of data-driven artificial intelligence to augment their visual analytical tasks. However, multiple factors come into play while training AI models in the domain of digital pathology, causing limitations in the performance and generalizability. Such uncertainty of performance creates a barrier that prevents AI from being adopted to assist diagnosis. Since AI models tend to be imperfect, we ask, when AI is still nascent and error-prone, how can physicians still make use of such imperfect AI in their existing workflow of diagnosis? To explore this question, we propose a series of collaborative techniques to engage human pathologists with AI, based on which we prototype Impetus, a tool where physicians can interactively train an imperfect tumor classification AI without incurring significant extra effort. We conducted work sessions with 8 medical professionals. By observing how they interact with Impetus, we summarize and conclude: lessons learned from designing an AI-enabled diagnosis tool for pathologists. Hi everyone, my name is Hongyan. This work was done at UCLA HCI Research in collaboration with Jingbin Huang, Lauren Huang, and my advisor, Xiang and Chen. In this work, we chose the medical application of breast cancer metastasis to explore the potential way that a doctor can use an imperfect AI. Here, pathologists need to locate the metastasis areas and diagnose according to the size of the metastasis. Starting from the disease type, we built Impetus AI's workflow surrounding human pathologists. For the AI's perspective, Impetus provides recommendation boxes, a map of outliers and certain regions to draw the attention of pathologists. While from the human perspective, pathologist users can provide labels to train the AI on the fly without incurring significant extra effort. Meanwhile, we split the roles of physicians and AI in the diagnosing task, partitioning the AI and physician-initiated actions. In Impetus, AI takes various degrees of initiative to assist pathologists, from full automation to complete invisible, based on its confidence. Next, let us walk through Impetus' scenario to see how the tool works with pathologists. The user first starts by importing multiple whole slide images into Impetus, while the system pre-processes these data. After that, the system calculates outliers and uncertainty regions to generate recommendation boxes and attention map. Then, the pathologist's attention is drawn to the recommendation boxes generated by the AI, which encompass regions of patches that visually appear to be outliers from the majority of cells. This suggests that these patches are likely to be tumor positive. With these automatic recommendations, Impetus alleviates the pathologist's burden of navigating a large high-resolution image. Next, the pathologist performs diagnosis by marking each recommendation box as either tumor or normal, and continue to manually select and label a few more regions on the whole slide image. As the pathologist makes such selections, their input is also collected by the AI to align itself with the pathologist's domain knowledge. After the AI is updated, Impetus recalculates and continues to provide new recommendation boxes for the user to label. Impetus also generates a prediction heat map with AI output probability. With the help of prediction heat map, pathologists can acknowledge the new change brought by the new labels immediately. Furthermore, Impetus can learn from pathologists' manually selected regions without forcing the user to mark a precise contour of a tumor region, which reduces the labeling burdens of pathologists. As the pathologist annotates more cases, AI takes the initiative to diagnose slides where it feels high confident. For mid-confidence slides, Impetus only provides a preview diagnosis suggestion for pathologists, where pathologists need to see the whole slide image to verify AI's recommendations. For the low-confidence slides, the AI almost becomes invisible, and the pathologist should proceed to finish the diagnosis task manually. we conducted work sessions of 8 pathologists in a local medical center to observe how pathologists use the tool to perform diagnosis. For the data, we used cysteine hematology and eosin stained sentinel lymph node sections from Chameleon 17 dataset. We led the users to diagnose breast cancer metastasis with a baseline image viewer called ASAP and Impetus. We also conducted a brief semi-structured interview for each participant to summarize their qualitative feedback. We further summarized these feedbacks into 6 lessons. Next, let me introduce these 6 lessons in detail. The first lesson is about recommendation boxes. We suggest medical AI systems provide instance-specific evidence that leads to a specific recommendation. We also suggest medical AI provide continuous guidance for pathologists, which leads to a second lesson. AI's recommendation need to continuously direct the medical user to filter and prioritize a large task space. For the third lesson, we suggest medical AI to demonstrate high-quality prompt for pathologists, where the AI's guidance, suggestions, and recommendations should be weighted by the amount of actual effort incurred. For the fourth lesson, we suggest medical AI provides functions to screen the slide first, that is, help doctors narrow a small regions from a large task space, helping them filter out information within specific regions. For the fifth lesson, we suggest show how AI improves, providing explicit feedback on how the model improves as a way to motivate future user engagements. Last but not least, we suggest medical AI provide information to validate its confidence level, especially for the cases where AI reports few positive detections. In summary, this paper explores how an imperfect AI can still benefit a diagnosis process on histological data. We investigate this question through Impetus, a tool where an AI takes multi-level initiatives to assist pathologists performing tumor detection. We conducted work sessions with medical professionals and summarized 6 lessons learned. We also provide design recommendations to inform future work on human-centered medical AI systems. Check out our paper to learn more about our findings, lessons, and design recommendations. Thank you.